Zinc as a building envelope, specification to installation. In Part 1, we'll cover zinc's architectural history, the roof substrate, and standing seam roofing. Some examples: interlocking panels at Holes Bay Pool, standing seam at Water End in the Lake District, bespoke rain screen facade in London, and standing seam in Malden, Essex. A satellite image, but of what? Paris, and the predominant colour is grey. The nature of the architecture chosen by Baron Haussmann in the middle of the 19th century, combined with the colour and availability of zinc, made it the ideal material. Much of this architecture required roofs to have a slope of 3 degrees. This is still the minimum slope for zinc roofs as built. Going below this slope greatly increases the chances of water ingress and staining, and is not recommended. Paris, and right, St Bartholomew's Church in Liège, the first ever zinc roof fitted in 1809. Zinc ore is relatively common. The richest areas are Peru and Canada, but zinc mines do also exist closer to home in Ireland and Sweden, and up until 1949 in the North Pennines. Traces of zinc were even found in the ruins of Pompeii. VMZINC has been produced continuously since 1837. Zinc was not only used in the redevelopment of Paris, but was also widely used in the UK for civic buildings, railway stations, King's Cross facade, top right, etc. in the 19th century. However, zinc's use in the UK, unlike in continental Europe, remained quite limited and indeed almost disappeared entirely by 1990. The Picton Reading Room Dome, Liverpool, was built in 1879 using zinc. After 133 years, many of the zinc panels were needing to be replaced. However, much of the original open-gap boarding was kept, thanks to good design and installation. While the vast majority of the original design was kept, 21st century regulations meant that panel width had to be reduced and standing seams were incorporated between the batten caps. Current corrosion rates are less than 2 microns per year. A sheet of zinc is at least 700 microns thick. A cold vented roof must have an air inlet at the base and air outlet at the ridge, minimum 10 mm open, a 50 mm deep continuous cavity between the back of the substrate and the installation. A larger cavity is fine, but not a smaller one. Plywood often uses slightly acidic glues, and during damp conditions these can get trapped between the zinc and the plywood. When a vented plywood deck is fitted, VMZINC Plus with a 60 micron underside coating should be used. VMZINC Plus protects the backside of the zinc from the non-compatible support. Vented, fully supported zinc roofs and walls follow Code of Practice 143-5 and British Standard EN 501. A warm, non-vented roof with insulation above the roof structure. A non-vented warm zinc roof must have a fully supported continuous self-sealing Aludex Max vapor barrier, a continuous layer of rigid insulation above the Aludex Max, reducing thermal bridges. VMZINC breather membrane, VMZINC Plus. In the UK, this means that the roof structure is entirely below the insulation. The structural roof has a BBA certificate and can be used with both PIR and mineral board insulation. Bearing plates and pegs greatly reduce thermal bridges, thus further enhancing the system. The fully supported Aludex Max vapor barrier, which increases air tightness, can be seen below the insulation, and the VMZINC breather membrane above. VMZINC standing seam roof systems are very flexible and can cover almost all forms. Furthermore, both warm and cold roofs have no fire penetration or flame spread following B-roof T4 tests. The right flashing must be used for the right detail. The G3 ridge offers a low-profile ridge. Eave details must deal with both thermal movement and be weathertight. Let's look at the G3 ridge and eave detail. The G3 ridge is an elegant, low-profile ridge that can be used on both warm, non-vented roofs as well as cold, vented ones. The ridge kit consists of a ridge cap, a connector piece, compression strip, and a color-coded stainless steel clip. As with all zinc roofing, specialist skills and tools are required. For a vented roof, a 30mm opening is required and can be covered with an insect mesh. For a vented ridge, the top of the standing seam panel requires a 15mm upstand. For a warm roof, this can be 25mm. At the eave, a standard T-plate is installed with clips. The hem at the bottom of the panel will depend on the panel length. 30mm for up to 7-meter panels and 50mm for panels up to 13 meters in length. For a dogtooth eave detail, the zinc should be punched. This eliminates the risk of any tearing of the zinc under high wind loading. A swept end eave is another option, but does take more time. At the ridge, the seams must be completely double seamed right up to the upstand. The ridge cap is placed over the ridge and the position for the clips is marked. The clips are then fitted with the bottom of the clip lining up with the mark. The compression strip is then fitted 10mm below the upstand. The strip should be 20mm wider than the zinc panel width. The ridge cap can now be fitted with the connector pieces. 2mm should be left between ridge caps. A number of options are available for the junction between the ridge and the verge. Every clip must be attached to the ridge with a stainless steel screw. The protective film can now be removed. A specialist job with specialist tools. We always recommend recognized installers. Zinc, copper and stainless steel should not be installed by a general builder. Most junctions on a zinc roof are mechanical, but some details, such as certain roof light details as well as gutters, require soldering. Zinc is a straightforward metal to solder. The right tools and materials must be used. For natural zinc and engraved Azengar, Zin 7 flux can be used to clean the surface. For all other finishes of zinc, including VMZINC Plus, the surface can be stripped back to bare zinc using a grinder with a plastic bristle. For quartz zinc and anthrazinc, Deca VMZINC can also be used to strip the surface back to bare zinc. A small amount of Deca VMZINC is poured into the soldering tray. Remember to close the lid on the Deca VMZINC. The scribe is used to mark the lower sheet of zinc at 55mm and another at 10mm. The scribe is then used to mark the upper sheet at 30mm. The protective film is removed. The Deca VMZINC is then slowly applied to a 30mm strip on the lower sheet. The zinc should be left for a few moments before being wiped clean with a cloth, revealing the shiny natural zinc. The same is then done with the upper sheet. The sheets are placed over each other and the top of the upper sheet is stripped. Before soldering, it is critical that clean, natural zinc is exposed. Zin 7 flux is then applied to the joint to be soldered. The soldering iron is heated to approximately 400 to 450 degrees centigrade and cleaned using the ammonia stone. The standard soldering stick is 60% lead and 40% tin and melts at 235 degrees centigrade. The first stage is 2-point solder so as to hold the two sheets together. For a flat soldered joint, the iron is then dragged over the joint, allowing the solder to penetrate between the two sheets. The soldering stick can be used to put pressure on the sheets whilst soldering. For areas where there may be more resistance, for example in a large box gutter, a reinforced soldered joint can be used. Clean the iron and check its temperature. Small strips of solder are then laid across the flat soldered joint at 25 mm intervals. A small amount of Zin 7 flux is added before pushing and pulling the small strips of solder into a more even layer. The protective film can then be removed. It should be noted that a properly soldered joint should be considered as part of a zinc roof and not something to hide.